What if the disasters shaking our planet aren't random at all? What if the violent earthquakes, the strange lights in the sky, and even the arrival of mysterious objects from deep space are all connected in ways we're only beginning to understand? Over the past few months, Earth has been anything but calm. Record-breaking quakes have rattled one of the most dangerous fault lines on the planet, while the sun itself has erupted with storms so powerful they painted the night sky with glowing auroras thousands of miles farther south than usual. At the same time, a visitor from outside our solar system has slipped silently into view, carrying with it a plasma cloud so massive it dwarfs our sun. These events on their own might be easy to dismiss as natural occurrences, coincidences in the endless chaos of the universe, but when they happen almost back to back, each one feeding into the next, the picture becomes harder to ignore. For centuries, people have looked at the skies for signs, believing that the heavens could influence life on Earth. Today, with satellites and telescopes capturing every detail, we've learned that space weather and earthly disasters may not be as separate as we once thought. A storm on the sun can ripple through our planet's magnetic field, altering currents deep underground. A comet rushing through the solar wind can create massive disturbances that spread across millions of miles. And sometimes, just sometimes, those ripples arrive right before the ground itself breaks apart. Scientists might call it coincidence, but the timing feels too precise, too haunting, to simply brush aside. As the weeks pass and the sun grows more violent, the question lingers: are we witnessing a chain of cosmic events that could shape the future of our planet, or just the universe reminding us how small we really are? The ground never gives a warning before it decides to let go. One moment, life continues as usual. The streets busy, the ocean calm, the mountains standing tall like they always have. Then, in a matter of seconds, everything changes. That's exactly what happened in the remote but volatile Kamchatka Peninsula, one of the most geologically restless corners of the Earth. In July of 2025, residents experienced something terrifying as the Earth unleashed a magnitude 7.5 earthquake, a force so violent that it shook buildings, tore open roads, and sent shockwaves rolling out across the Pacific. People who had lived their whole lives in this region, already familiar with smaller quakes, described it as something different, something that felt unnatural in its suddenness and raw energy. Many thought that was the end of it, that the worst had passed. But the Earth wasn't done. Just weeks later, in September, the same region was hit again, this time by an even more powerful monster, an 8.8 magnitude quake that ripped through the crust with enough strength to rank among the largest earthquakes ever recorded in human history. The second quake was brutal not only because of its raw magnitude, but because of where it struck. Kamchatka sits on the Pacific Ring of Fire, a place where tectonic plates grind against each other relentlessly, and every so often, the pressure builds to the point of catastrophic release. For centuries, scientists and local people alike have known this region is a powder keg, but the speed and scale of these twin events caught everyone off guard. Entire towns were left scrambling for safety as aftershocks continued, some nearly as strong as the main quake itself. Tsunami warnings rippled out across the Pacific, echoing memories of other disasters like the 2011 Tohoku quake in Japan, which had triggered one of the most devastating tsunamis of modern times. When the September quake struck, residents near the coast scrambled inland, fearing the worst. Waves did rise, though thankfully not to the apocalyptic levels some had feared. But the damage on land was undeniable. Infrastructure collapsed, roads twisted into useless ribbons, and communities already fragile found themselves cut off, isolated and desperate for relief. For those watching from afar, these events seemed like yet another chapter in Earth's endless cycle of destruction and renewal. After all, earthquakes have always been part of our planet's story, but what made this sequence so unsettling was how close together they were, and how unusually large the second one turned out to be. It's one thing for a region like Kamchatka to experience a strong quake every decade or two, but for two massive ones to strike in just over 2 months, one of them nearly reaching the maximum strength an earthquake can physically achieve, that raised questions. Scientists immediately began combing through seismic data, comparing the timing, the depth, the aftershock sequences, searching for any pattern that might explain why this happened now, and why with such ferocity. The more they looked, the stranger it became. Eyewitnesses described not only the shaking, but also eerie atmospheric phenomena that accompanied the quakes. Strange lights flickered in the night sky, glowing pulses that some compared to auroras, though they were seen in places far from any northern lights activity. These luminous glows, known as earthquake lights, have long been dismissed by many scientists as folklore, but in recent years, evidence has piled up that they are very real. They seem to appear when massive stresses in the Earth's crust suddenly release, sending bursts of electrical energy into the atmosphere. In Kamchatka, dozens of witnesses filmed these glowing flashes during the September quake, and the footage quickly spread online, sparking debates not just among geologists, but among those who believe earthquakes might be connected to forces far larger than shifting tectonic plates. Was the Earth itself sending out a signal, or was there something happening above, in the skies and in space, that was amplifying the violence below? The human toll was equally haunting. Families displaced, schools collapsed, and critical infrastructure like hospitals strained under the sudden influx of the injured. Relief agencies had to navigate not only the wreckage but also the psychological trauma of communities living in constant fear of the next tremor. After the July quake, people had tried to resume normal life, patching up damage and rebuilding what they could. But after September, the fear became heavier, a weight pressing down on entire towns. Parents hesitated to send their children to school in buildings that might not withstand another hit. Fishermen feared heading out to sea, worried that another hidden rupture could send walls of water crashing back toward shore. Life in Kamchatka has always been precarious, balanced between beauty and danger, but now it felt like the land itself was turning hostile, restless, almost alive in its anger. Geologists pointed out that the September quake was close in strength to the 1960 Chilean quake, the most powerful ever measured at a staggering magnitude 9.5. Quakes of this size don't just release energy locally, they send ripples around the world. Seismic waves travel through the Earth's core, bouncing back and forth, subtly destabilizing fault lines on the other side of the planet. Instruments picked up those waves in South America, in the mid-Atlantic, even in distant Africa. The planet had quite literally rung like a bell, and when the Earth rings, there are often echoes, after effects, that can trigger other fault lines to fail days or even weeks later. Scientists and citizens alike began to wonder, if Kamchatka had been struck so violently, what region might be next? And would the aftershocks be confined to local cracks in the crust, or would they extend outward, nudging another vulnerable zone into collapse? As terrifying as the ground shaking was, what unsettled many researchers even more was the timing. These quakes did not occur in isolation from other global events. Just days before the September catastrophe, Earth had been struck by a geomagnetic storm from the Sun, a storm powerful enough to ignite auroras in skies as far south as Colorado, well beyond their usual territory. Solar storms of that magnitude don't just paint the skies, they also inject enormous amounts of energy into Earth's magnetic field, inducing currents that ripple through the crust itself. For most people, that just means potential disruptions to satellites or power grids. But for those studying earthquake triggers, the coincidence was striking. Could the same geomagnetic energy lighting up the atmosphere also have destabilized a fault line already straining under pressure? Could space weather, in other words, have been the invisible hand that pulled the trigger on one of the most powerful quakes in recent memory? Officially, mainstream science remains cautious, reluctant to connect solar storms to seismic events. Yet off the record, even seasoned geologists admitted the timing was suspiciously close. For the residents of Kamchatka, of course, these debates offered little comfort. They weren't interested in whether the sun, or planetary alignments, or some interstellar visitor had played a role. They only knew that their homes were broken, their routines shattered, and the ground beneath their feet no longer felt secure. But for those paying attention beyond the immediate devastation, Kamchatka's twin earthquakes seemed less like isolated tragedies and more like part of a larger pattern unfolding across the planet. As September bled into October, with the sun entering a violent peak in activity and strange objects drifting through the solar system, the question became impossible to ignore. Was the Earth simply going through a natural cycle of seismic unrest? Or was it being pushed, pulled, and provoked by forces from above? And if so, what might come next, now that the planet had already shown just how easily it could be shaken to its core? The sun has always been more than just the source of light and warmth for life on Earth. To ancient civilizations, it was a god, a blazing force of creation and destruction that dictated the cycles of planting, harvest, drought, and flood. Today, with modern science, we no longer worship it as a deity, but in many ways, it still controls us more than we like to admit. Every flicker on its surface, Every eruption of plasma, every sudden twist in its magnetic field, sends waves of energy rippling across the solar system, and when those waves reach Earth, they can rewrite our reality in ways most people never notice until something goes wrong. In 2025, the sun is once again awake, alive with fury, and the timing of its awakening couldn't be more unsettling. For years, scientists had warned that solar cycle 25 would reach its peak around this time, but what they didn't expect was just how quickly it would ramp up and how violently it would lash out. In mid-September, just days before the second massive Kamchatka earthquake, the sun unleashed a storm unlike anything Earth had felt in years. On September 14th and 15th, charged particles blasted outward from a gaping hole in the sun's corona, a region where the star's magnetic field lines opened wide like cracks in its fiery skin, creating a direct pipeline for solar wind to pour through. These coronal holes might sound small or obscure, but in reality they can stretch across a fifth of the sun's surface, spewing streams of high-speed plasma into the solar system for days, even weeks. One of these streams barreled straight toward Earth, colliding with our planet's magnetic shield and triggering what scientists call a G3 geomagnetic storm. For those not steeped in technical jargon, a G3 is considered strong and can disrupt satellites, scramble GPS signals, interfere with radio communication, and in some cases, even overload power grids. But it also paints the sky with colors shimmering curtains of green, purple, and red light that ripple across the night as the aurora borealis comes alive. That week, people who had never in their lives seen the northern lights suddenly found themselves staring in awe at the heavens. Reports came in from Colorado, Missouri, even parts of France where auroras are almost unheard of. Social media lit up with photographs and shaky videos of skies glowing electric green above neighborhoods that usually never see such phenomena. For many it was magical, for others it was unsettling. The aurora is beautiful, yes, but it is also a symptom, a visible reminder that Earth's magnetic field is under siege. And the stronger the storm, the deeper that energy penetrates into the planet's system. Scientists tracking the solar wind speed noted that it surged past 700 kilometers per second, nearly double its usual rate. That kind of energy doesn't just bounce off Earth's defenses, it seeps in, it crackles through the upper atmosphere, and it induces electrical currents that snake through the ground itself. Under the right conditions, those currents can destabilize fragile infrastructures like power lines and pipelines. But could they also, as some researchers suggest, destabilize fault lines buried deep in Earth's crust? This is where the story begins to drift from accepted science into the shadows of speculation, a place where curiosity and controversy mix. Officially, most geologists will tell you that earthquakes are purely the result of tectonic pressure, the slow grinding of plates that eventually snap when stress becomes too much. Solar storms, in their view, have nothing to do with it, and yet, time and again, major earthquakes seem to cluster around times of heightened solar activity. The September Kamchatka quake struck only 3 days after the G3 geomagnetic storm. Is it coincidence? Or is it cause? No one can say for sure, but the suspicion lingers, whispering at the edges of scientific debate. The truth is, we still don't fully understand the complex ways Earth's systems interact. We know the magnetic field shields us from cosmic radiation. We know electrical currents course through the planet during geomagnetic storms. We know stress builds invisibly in the crust, waiting for a trigger. Could the two processes collide, one amplifying the other? The possibility is unnerving, because if true, it means Earth's most destructive natural disasters might not be entirely terrestrial. They might be written, at least in part, by the moods of the sun. Even more mysterious was the source of the September storm itself. Most people think of solar storms as the aftermath of giant solar flares, those explosive bursts of light and radiation that can be seen even from millions of miles away. But this wasn't a flare. It wasn't a coronal mass ejection either, at least not in the traditional sense. Instead, it was the quiet, relentless streaming of plasma from a coronal hole that had rotated into view, almost like an open wound staring straight at Earth. In some ways, these holes are more dangerous than flares, because they can persist for multiple rotations of the sun, striking Earth again and again like the drumbeat of an invisible war. Every time the sun spins around, the same hole can hurl another barrage, and each time Earth's magnetic field takes another hit. The September storm wasn't a one-off. It was part of a pattern, a warning sign that the sun was entering a phase of prolonged unrest. As solar cycle 25 continued to intensify, scientists warned that storms of this scale, and worse could become a regular occurrence over the next year. And if even one of those storms coincided with another fragile moment in Earth's crust, the results could be catastrophic. For those who spend their lives studying the sun, the events of September were both thrilling and alarming. Thrilling because it's rare to see such a direct and powerful interaction between our star and our planet. Alarming because it reminds us how vulnerable we really are. In 1859, a storm known as the Carrington event sent telegraph wires sparking and set offices on fire. If a storm of that scale were to happen today, experts say it could cripple satellites, collapse power grids, and plunge much of the world into darkness for weeks, even months. September's storm wasn't on that level, but it was enough to expose weaknesses. Airlines reported radio blackouts on polar routes. Satellites experienced temporary malfunctions. Amateur radio operators noticed entire frequency bands disappearing into static. And beneath it all, the Earth itself trembled days later, as if responding to some cosmic cue. Whether connected or not, the sequence felt like a foreshadowing, a hint that the boundaries between space weather and Earth's seismic heart may not be as clear as we once thought. What makes all this even more chilling is the sense of timing, the way events seem to line up as though orchestrated. The sun roars awake with a G3 storm, painting skies in colors no one expected. 3 days later, Kamchatka quakes with near-record violence. Weeks later, an interstellar comet with a plasma coma larger than the sun drifts into the inner solar system, just as the sun grows more violent still. Each event, taken alone, might be shrugged off. Together they weave a narrative too compelling to ignore. For centuries, humans have told stories of omens in the sky, of celestial signs warning of disasters to come. In the 21st century, with all our science and technology, we like to believe we've outgrown those myths. But what if those myths were only crude interpretations of something real, something our ancestors sensed long before satellites gave us the proof? Perhaps the universe does leave hints, scattered in the timing of storms, quakes, and comets, and perhaps we're only now learning to recognize the patterns for what they are. The September solar storm wasn't the largest in history, nor the most destructive, but in the context of everything else unfolding, the earthquakes, the strange lights, the cosmic visitors, it felt like a chapter in a larger story that is still being written. The sun is awake, restless and unpredictable. Its storms don't just belong to the sky, they ripple through every part of our world, from the satellites overhead to the tectonic plates under our feet. And as the cycle intensifies, one haunting question grows louder. If this was just the beginning, what kind of storm is still waiting on the horizon? Coincidence is a word we use when we don't yet understand the pattern. It gives us comfort, a way to dismiss strange timing as nothing more than chance, like rolling 2 sixes in a row or meeting an old friend in a city halfway around the world. But when the ground splits open days after the sky itself has been torn by a storm of solar fire, the word coincidence feels weaker, almost hollow. That's the uneasy feeling scientists and ordinary people alike carried with them after September of a powerful geomagnetic storm from the sun, auroras glowing in unexpected skies. Then, just 3 days later, one of the strongest earthquakes ever measured ripping through Kamchatka. It begs the question, are these events unrelated, or are we glimpsing a deeper link between Earth and the star that gave it life? The debate isn't new, but the timing of these events has forced it back into the spotlight with renewed urgency. Mainstream geology insists earthquakes are purely tectonic. Plates grind, pressure builds, stress is released, and the result is seismic chaos. This model has served us well for decades, explaining most of the world's seismic activity with impressive accuracy. Yet the theory begins to fray at the edges when timing like this arises. Skeptics argue that with thousands of earthquakes every year, some are bound to coincide with solar storms purely by chance. But the Kamchatka quakes were not ordinary. A 7.5 followed by an 8.8 in such short succession is rare. To have the second monster rupture mere days after Earth's magnetic field was battered by charged particles from the sun makes the coincidence argument harder to swallow. It feels less like rolling dice and more like pulling on a thread that unravels something bigger. And the unsettling truth is, we don't yet know how deep that thread goes. Some scientists outside the mainstream have spent decades chasing this very question. They point to historical records, noting clusters of major earthquakes, aligning suspiciously close to peaks of solar activity. They highlight how geomagnetic disturbances penetrate deep into the Earth, inducing currents that flow through the crust itself. These aren't the kinds of electrical surges that blow out your light bulbs. They're subtle but vast, spreading across hundreds of miles, and in places where fault lines are already straining, even a slight nudge might be enough to tip the balance. Imagine a boulder perched on the edge of a cliff. It doesn't take a storm to move it, just the vibration of a passing truck. Could Earth's faults be the same, waiting for a whisper of solar energy to slip past the magnetic shield and shake loose what was already inevitable? The possibility is difficult to prove, but it's also difficult to dismiss. Still, the scientific community remains divided. For every paper suggesting a link, another insists there is none. The problem lies in scale. Earthquakes are highly localized, tied to the quirks of individual faults, while solar storms blanket the globe in their effects. It's like trying to prove a lightning strike caused a single leaf to fall in a forest where millions are already dropping. The signal gets lost in the noise. And yet, time and again the timing reappears, teasing the possibility of a hidden mechanism at work. If coincidence is truly the answer, then why does it keep happening with such unsettling precision? Why do we keep seeing one event follow so close on the heels of another, as if the planet and the sun are locked in a secret dialogue we've only just begun to overhear? Beyond the scientific debate, the psychological effect of these coincidences is undeniable. For people living in Kamchatka or anywhere prone to earthquakes, knowing that the sun's moods might have a hand in their fate adds a new layer of dread. It means danger could come not just from the slow grinding beneath their feet, but from the fiery storms millions of miles away, storms they can't see or predict without the help of satellites and scientists. It makes the world feel more fragile, more connected in ways we struggle to comprehend. And for those watching from afar, the coincidences stir something older, something primal, the idea that the heavens do send warnings, that disasters are written in the stars. We like to think of ourselves as rational beings in the 21st century, immune to superstition. But when events align with such haunting timing, even the most rational minds can't help but wonder if there is meaning in the chaos. The September sequence was particularly eerie because of its layering. First came the solar storm, visible in glowing skies that reached into regions unaccustomed to such displays. Then came the quake, tearing open the crust and producing mysterious earthquake lights of its own, as though the earth was mirroring the heavens in its own way. The two events seemed to echo each other: light in the sky, light from the ground, magnetic fury above, seismic fury below. If they were truly unrelated, the synchronicity was extraordinary. But if they were connected, then we might be standing at the edge of a new understanding of Earth, one where cosmic and terrestrial disasters are part of a single system, not separate chapters. Adding to the mystery was the fact that this wasn't the first time such suspicions had arisen. In 1989, a geomagnetic storm strong enough to black out Quebec occurred around the same time as increased seismic activity in Alaska. In 2004, during one of the most active solar years in decades, a devastating earthquake and tsunami struck Indonesia. Again, coincidence? Perhaps, but the pattern has appeared often enough that it gnaws at the edges of certainty. If we could prove even a slight correlation, it would change how we prepare for disasters. Monitoring solar activity could become as important as monitoring stress along fault lines, giving us a new tool to predict the unpredictable. But until then, we're left in the uncomfortable space between belief and denial, where evidence is suggestive but not conclusive, and where coincidence may not be enough to explain what we see. In the days following the September quake, these questions filled scientific forums, news broadcasts, and online discussions. Some dismissed the connection outright, calling it pseudoscience. Others insisted the evidence was mounting, even if the establishment refused to admit it. And while experts argued, ordinary people watched the skies with a mix of awe and fear. They saw auroras dancing where none should be, then watched the ground tremble days later, and they couldn't help but connect the dots in their own way. Humans are natural storytellers. We seek patterns even where none exist. But sometimes, the stories we tell hint at truth science hasn't yet caught up to. Perhaps coincidence is the wrong word. Perhaps what we're witnessing is correlation without explanation, a connection waiting to be understood. What unsettles many is the thought that if these events are linked, the implications stretch far beyond one region or 1 month of disaster. It suggests that our planet's greatest catastrophes may be influenced by forces completely outside our control, forces we can't predict with our current tools. It means the sun's temper, the alignment of planets, even the arrival of strange objects from interstellar space, might play roles in shaping Earth's destiny. That idea borders on heresy for traditional science, but it resonates deeply with something intuitive, something we've sensed for millennia, that we are not isolated, that the Earth is part of a cosmic web, and when one thread trembles, the whole web feels it. So was the September sequence mere coincidence? Or was it a message written in solar fire and seismic stone, a reminder that Earth and Sun are not separate, but intertwined in ways we are only beginning to fathom? The debate may rage on, but one thing is clear: the timing was too sharp, the sequence too haunting, to be ignored. Coincidence can only carry the weight of explanation for so long. Eventually, patterns demand answers, and in the wake of Kamchatka's fury and the Sun's awakening, the search for those answers has only just begun. Every once in a while, the universe sends us a reminder that we are not alone in the endless sea of stars. For most of human history, comets have played that role. They arrive suddenly, blazing across the night sky with tails that stretch farther than the eye can follow, and then vanish into the blackness again. To ancient peoples, they were omens of doom, heralds of disaster, messengers of the gods. Today, science strips away the myth and tells us they are nothing more than dirty snowballs, chunks of ice and dust left over from the birth of the solar system. Yet every now and then, one appears that refuses to fit into the neat categories we've created, something that unsettles even the most rational minds. In 2025, such a visitor slipped silently into our skies: Comet 3I Atlas, the third interstellar object ever detected. Unlike the countless comets that orbit our sun, this one came from somewhere else entirely, a wanderer from another star system, carrying with it mysteries we may never fully understand. The discovery was met with awe, but also with disbelief. Astronomers had already been shocked when the first interstellar object, Oumuamua, was detected in 2017, tumbling through the inner solar system on a path that proved it had come from far beyond our sun's reach. Then came 2I Borisov in 2019, a more traditional comet, but still undeniably interstellar. Each had challenged our understanding, but Comet 3I Atlas felt different from the start. For one thing, it wasn't shy. Most comets only begin to release gas and dust, the process we call outgassing, when they get close to the sun, warmed enough for their frozen cores to vaporize. But Atlas began glowing long before it reached that point, millions of kilometers from the sun, shedding material in a way that defied expectation. It was as if this visitor carried an energy of its own, something primed to awaken before any solar heat touched. As weeks passed and telescopes tracked its approach, the scale of the comet became clear, and with it the sense of unease deepened. The coma, the hazy cloud of gas and dust that surrounds a comet's nucleus, was unlike anything ever recorded. It expanded rapidly until its size was measured in terms that sound almost impossible to believe, half the diameter of the sun itself. To picture this is to stretch the imagination. Our sun, a star that could fit more than 1 million Earths inside it, suddenly dwarfed by the sheer bubble of plasma and dust surrounding a cosmic traveler. Even if the nucleus itself was modest, the sphere of influence it carried was immense, a kind of plasma cocoon that no other comet in human memory had displayed on this scale. Scientists called it extraordinary. Others called it ominous. The more data flowed in, the stranger Atlas became. Its path through the solar system was hyperbolic, meaning it wasn't bound by the sun's gravity. It would come, pass by, and leave, never to return. That alone is unsettling, because it means this isn't a neighbor from the Oort cloud or some fragment from the Kuiper belt. This is an alien, a true foreigner, born in the chaos of a star system we've never seen, carrying with it the fingerprints of an entirely different sun. What secrets are frozen in its ices? What stories does its dust tell? And more importantly, what effect might it have on the delicate balance of our own system as it cuts across the solar wind like a ship carving through a stormy sea? For many watching its arrival, the timing was too strange to ignore. Earth had just been shaken by quakes of historic force. The sun had erupted in storms of light and energy, and now here came a visitor cloaked in plasma, drifting into the heart of the action as though drawn to the chaos. Scientists remained cautious, insisting that comets do not trigger earthquakes, that interstellar objects have no effect on tectonic plates or geomagnetic storms. But others outside the mainstream began to whisper darker possibilities. Could a comet with such an enormous plasma envelope disturb the sun itself as it passed, amplifying the already restless cycle of storms? Could it alter the flow of solar wind, redirecting streams of charged particles toward Earth. After all, comets interact with solar plasma constantly, generating shock waves and magnetic disturbances as their ion tails stretch millions of kilometers behind them. If a normal comet can do this, what might one of unprecedented size achieve? The questions didn't stop there. Some dared to suggest that such an object might not be entirely natural. Mumamoa had already sparked speculation years earlier, when its strange acceleration couldn't be explained by traditional physics. Some suggested it was a fragment of alien technology, a derelict probe from another civilization. Those claims were dismissed, but the unease lingered. Now, with Atlas arriving in the midst of solar chaos and planetary turmoil, the whispers grew louder. Was it possible that this wasn't just another wandering rock but something more deliberate? Its coma, so massive and luminous, reminded some of a plasma sail, a theoretical technology designed to harness the solar wind for propulsion. Science fiction, perhaps, but not outside the realm of possibility. If intelligent life elsewhere had built such a device, might it look exactly like this? A colossal glowing sphere drifting silently into our star's domain. Of course, the majority of scientists pushed back against such speculation, pointing out that extraordinary claims require extraordinary evidence, and there was none, at least none, that couldn't be explained by natural processes. And yet, the sheer strangeness of Atlas left the door cracked open, just wide enough for imagination to slip through. Its timing, its size, its behavior, none of it fit neatly into the expected patterns. And when things don't fit, they demand attention. For the public, the story wasn't about dry data or orbital mechanics. It was about mystery, the thrill of knowing that something truly alien was passing through our skies, something not bound to the familiar cycles of our own solar system. It was a reminder that we are not the center of the universe, just one stop along an endless highway of cosmic travelers. For Earth, though, the comet's presence was more than a curiosity. Its vast coma interacted with the solar wind in ways still not fully understood, creating ripple effects across the heliosphere. Some observers noted unusual fluctuations in solar activity as it drew closer, though no definitive link could be proven. To those already shaken by quakes and storms, it felt like another piece of the puzzle, another sign that forces far beyond human control were aligning. The Earth trembles, the sun erupts, and now the stars themselves send a visitor cloaked in fire. If it was all coincidence, it was a coincidence that felt like destiny. The story of Atlas is still unfolding, its trajectory carrying it past the inner planets, and eventually out into the dark once more. It will not return. In a few months it will vanish from our skies, shrinking back into invisibility as it speeds away toward the unknown. But the questions it leaves behind will remain. Why here, why now, and why in such extraordinary form? Was it simply a piece of interstellar debris, a frozen relic wandering aimlessly until chance brought it past our sun? Or was its arrival part of something larger, a cosmic choreography we have not yet learned to read? Whatever the answer, one truth is undeniable. For a brief moment in time, Earth and its restless inhabitants looked up and saw something that came from another world, and in its shimmering glow, they felt both wonder and unease. The interstellar intruder had arrived, and its presence could not be ignored. Beneath the surface of our world, hidden from sight, an invisible pulse is always flowing. Most people never think about it, but Earth is not just a ball of rock wrapped in air and water. It's also a living electrical system. The crust, the mantle, the molten core, and the magnetic field surrounding it all work together like the circuitry of some vast machine. When lightning strikes, when solar storms hit, when magnetic lines snap and reconnect in the sky above us, currents ripple through the planet's body, coursing through stone and ocean alike. Scientists call them telluric currents, but the phrase does little to capture their raw significance. They are Earth's heartbeat, steady but responsive, always shifting in rhythm to the energy that rains down from space. And in moments of cosmic unrest, like the storms and quakes of 2025, that heartbeat grows louder, pulsing in ways that leave us wondering whether the planet is simply reacting or whether it is alive in ways we barely understand. To appreciate this hidden system, you need to imagine Earth as a conductor, like a vast wire strung through space. The sun sends streams of charged particles, plasma really, hurtling outward in all directions. When those particles collide with Earth, they don't just bounce off, they interact with our planet's magnetic field, compressing it, shaking it, sometimes piercing it altogether. The energy has to go somewhere, and often it dives into the crust itself, spreading out as electric currents that run silently beneath our feet. They are invisible, but their fingerprints can be measured. Instruments buried in the ground pick up fluctuations as these currents wax and wane, sometimes gentle, sometimes powerful enough to destabilize power grids or interfere with pipelines. The 1989 blackout in Quebec was one such reminder, when a geomagnetic storm sent surges racing through transmission lines until the grid collapsed. That was a human-made system failing under the weight of Earth's heartbeat. But what about natural systems? What about fault lines stretched to their limit, ready to break? Could these electrical surges act like the last straw, the vibration that tips a fragile structure into collapse? That question becomes especially haunting when we look at what happened in September. A G3 geomagnetic storm roared across the planet, its energy stirring currents from pole to pole. 3 days later, Kamchatka ruptured with a quake so massive it shook the entire Earth. The official explanation remains tectonic pressure. The plates were primed, and the quake was bound to happen sooner or later. But perhaps sooner was dictated by something more. Imagine a fault line as a wound in the Earth's crust, scarred and waiting to tear again. Pressure builds quietly for years, decades, even centuries. Then on a random day, the balance tips, and the rupture cascades outward. Why that day? Why that moment? It may not be random at all. It may be that when Earth's electrical heartbeat surges under the pressure of a solar storm, the currents seep into the rock, subtly altering stress, weakening friction, loosening bonds. In that fragile instant, the wound splits wide open, and the world above is forever changed. Some scientists have begun to explore this very idea. They study the correlations between geomagnetic disturbances and seismic activity, compiling data that hints at an uncomfortable truth. The timing is not always accidental. There are spikes in earthquake frequency following strong geomagnetic storms, particularly in regions already under strain. These researchers propose that electromagnetic energy may play a role in destabilizing faults, not as the root cause but as a trigger, the final flick of the domino that was already leaning. The mainstream still resists this notion, but the evidence continues to grow. And when you look at events like those in 2025, it's hard not to feel that the Earth's pulse and its quakes are two sides of the same story. What makes this even more eerie is the way Earth itself seems to respond visibly. During powerful quakes, witnesses often report strange lights in the sky, flashes, glows, shimmering curtains of color. For centuries these were dismissed as myth, yet in recent years cameras have caught them, undeniable and real. They are believed to be caused by surges of electrical energy released from the crust, ionizing the air above fault zones. In other words, when the Earth breaks, it sparks like a short-circuited wire. The September quake produced exactly this phenomenon, with videos showing eerie blue glows rippling through the sky even as the ground roared beneath people's feet. In that moment, the Earth's heartbeat wasn't just invisible, it was visible to anyone who dared to look up. Think about the symbolism of that. The sky lights up with auroras during a geomagnetic storm, glowing with energy pouring in from above. Days later, the ground lights up with earthquake lights, glowing with energy pouring out from below. Two halves of the same pulse, one driven by the sun, the other by the Earth's breaking skin. Coincidence? Perhaps. But to many it looked like the planet's circuitry had been overloaded, and the evidence was written in glowing fire across both heavens and horizon. The concept of Earth's electrical heartbeat is not purely poetic. It is measurable, quantifiable, and increasingly studied. Magnetometers track fluctuations in the field, seismographs record subtle vibrations, and researchers are beginning to overlay these datasets to see where they overlap. What they find is unsettling. Patterns that suggest earthquakes are more likely to occur during times of high geomagnetic activity. Not guaranteed, but more likely. If proven, this could change everything about how we prepare for disasters. It would mean earthquake prediction might one day involve monitoring space weather as closely as tectonic pressure, watching not only the shifting of plates but the storms of the sun. It would mean Earth is more deeply tied to the cosmos than we've allowed ourselves to believe. For the ordinary person, the science may seem distant, but the implications are not. It means that when the sun erupts, it's not just satellites and astronauts at risk. It could be all of us, living on a planet whose crust may be more sensitive to those surges than anyone wants to admit. It means that the heartbeat of Earth is not entirely its own, but synced, in some strange way, to the heartbeat of the sun. And that realization carries with it a new kind of vulnerability, one that stretches far beyond the simple fear of the ground shaking. It suggests that cosmic weather and earthly disaster are part of one grand rhythm, a rhythm we're only now beginning to hear clearly. In the days after the September quake, as the data poured in, scientists debated, governments scrambled to respond, and ordinary people tried to rebuild their lives. The planet's invisible pulse kept flowing. It does not stop, it does not rest, and as long as the sun continues to burn, it never will. But with each surge, each storm, each tremor, the world is forced to confront a possibility too big to ignore. The Earth's electrical heartbeat may be more than just background noise. It may be the metronome of catastrophe, ticking away in sync with the storms of the cosmos, waiting for the next fragile moment to make itself felt. For centuries, humans have tried to explain why the ground sometimes shatters beneath their feet. Ancient cultures spoke of angry gods, mythical beasts slumbering under the earth, or cosmic punishments written into the sky. Modern science stripped away those myths and replaced them with the cold precision of plate tectonics, and yet, for all our advances, earthquakes remain among the least predictable disasters on Earth. We can measure pressure building on a fault, we can track microquakes, and we can model probabilities, but we still cannot say when the next rupture will come. That uncertainty has driven some researchers to look beyond the ground and into the sky. Among the theories that emerge from this search, one of the most controversial and fascinating is what some call the earthquake generator theory, the idea that solar storms, by disrupting Earth's magnetic field, can act like a cosmic trigger for seismic activity, pulling quakes out of the crust before they were destined to arrive. The heart of this theory lies in the strange way energy moves between the sun and our planet. When the sun erupts, whether in a flare, a coronal mass ejection, or even the steady streaming of plasma from a coronal hole, it sends charged particles hurtling toward Earth. These particles slam into our magnetic shield, distorting it, compressing it, sometimes even puncturing it. As they do, they generate currents that ripple through the atmosphere and into the ground. Normally, these geomagnetically induced currents are weak, barely noticeable outside of sensitive instruments, but during strong solar storms, they surge. In those moments, Earth becomes a conductor in a vast electric circuit stretching across millions of miles of space, and when electricity flows through rock, it can alter the stresses already hidden inside. Faults straining under centuries of pressure may suddenly find their friction reduced, their delicate balance disrupted. In this view, the earthquake generator is not some mechanical device, but the sun itself, using Earth's own magnetic skin to reach deep into its body and pull at the wounds already waiting to tear. Critics of the theory argue that the energy involved is simply too small. Compared to the unimaginable forces stored in Earth's crust, they say, the currents from space are like whispers against a hurricane. How could such subtle flows matter in the face of tectonic titans? But supporters counter that the question isn't about raw energy, it's about timing and thresholds. A single grain of sand means nothing on a sturdy surface, but on a scale already balanced to tipping, it can bring down the entire pile. In the same way, a fault line on the verge of rupture may not need a vast push. It may need only the faintest touch at just the right moment. And the earthquake generator theory suggests that geomagnetic storms supply exactly that touch. It doesn't create earthquakes where none were building, but it may choose the moment they arrive. The September 2025 quake in Kamchatka provided one of the most compelling case studies yet. Just 3 days earlier, Earth had been struck by a G3 geomagnetic storm, sparked not by a massive solar flare, but by the relentless streaming plasma of a coronal hole. The storm lit up skies as far south as Colorado, painted Europe in auroras, and disturbed satellites and radio networks. Scientists measured intense fluctuations in geomagnetic currents across the planet. Then, as if on cue, the Earth cracked with an 8.8 quake, one of the most powerful in recorded history. The proximity of these events was impossible to ignore. For many, it seemed like a textbook demonstration of the earthquake generator idea. The planet had been primed, the sun had delivered its blow, and the result was catastrophic release. The theory goes even further, suggesting that solar storms may create what some researchers call a vacuum effect in the magnetic field. As plasma streams past Earth, the magnetic shield deforms, stretching and snapping in ways that alter the flow of energy around the planet. Some models propose that this sudden redistribution of electromagnetic forces could cause shifts not only in the ionosphere but in the lithosphere beneath it. The crust and the sky may be more deeply linked than we've dared to admit. In this vision, the earthquake generator isn't just a trigger, but a complex interplay between celestial and terrestrial systems, with the sun's moods echoing directly into the planet's bones. Evidence for this theory has been quietly building. Researchers have documented clusters of earthquakes following strong geomagnetic storms, noting that the probability of seismic activity seems to rise in the days immediately afterward. The correlation isn't perfect, and it doesn't apply to every quake, but the pattern recurs often enough to keep the question alive. Some of the strongest quakes in history, from Chile in 1960 to Indonesia in 2004, have coincided with heightened solar activity. The 1989 storm that blacked out Quebec was followed by a swarm of quakes in Alaska. Even the Great Tohoku quake of 2011, which triggered the Fukushima disaster, occurred during an active phase of the sun. These connections may still be circumstantial, but taken together they paint a picture too suggestive to ignore. If even a fraction of earthquakes are nudged into existence by solar storms, it would revolutionize our understanding of natural disaster. Of course, the mainstream remains skeptical. Earthquakes are notoriously difficult to predict, and adding cosmic weather to the equation complicates an already messy field. To many, the earthquake generator idea sounds like grasping at straws, another pseudo-scientific attempt to find patterns in chaos. But history has shown that radical ideas often start at the fringes, ridiculed before they are studied seriously. Once the notion that the continents drifted across the globe was dismissed as fantasy. Once the idea that invisible microbes caused disease was laughed at. Today, both are cornerstones of science. Could the earthquake generator theory one day join them, moving from speculation to accepted fact? The possibility lingers, especially in the wake of disasters that align so perfectly with cosmic disturbances. Beyond the scientific debate lies the deeper psychological impact. The earthquake generator theory suggests that Earth is not an isolated system, grinding away under its own weight, but part of a vast electrical web that stretches from our planet to the sun and beyond. It suggests that our disasters are not entirely our own, but influenced by forces from the stars. That idea is both terrifying and humbling. It means that when the sun erupts, we may feel its wrath not only in the skies above, but in the ground beneath. It means that cosmic weather and earthly catastrophe are woven together in ways we're only beginning to perceive. And it means that our planet is more alive, more interconnected with the universe, than our narrow models have allowed us to imagine. The September events left many with the chilling impression that the earthquake generator had just flexed its power before our eyes. The sun had stirred, Earth had answered, and the timing was too sharp to dismiss. Whether or not science eventually proves the theory, the experience of living through those days was enough to plant the seed of doubt. Perhaps earthquakes are not only the result of grinding plates, but also of solar whispers carried on the currents of space. Perhaps our planet's greatest disasters are chosen not solely by geological destiny, but by a dialogue between Earth and Sun, a dialogue as old as the stars themselves. And if that's true, then we must rethink how we prepare for the future. Watching fault lines may not be enough. We may need to watch the skies as well, listening for the heartbeat of the sun as carefully as we monitor the strain of the crust. Because if the earthquake generator is real, then every solar storm is more than just a light show in the heavens. It is a warning that the ground itself may be preparing to shift, and the next time the sun lashes out, the earth may once again answer with a roar that shakes us all. The September quake in Kamchatka, shadowed by the geomagnetic storm that lit up the skies just days earlier, already felt too precise to be dismissed. But hidden in the background of those days, another cosmic coincidence was quietly unfolding, one that many observers overlooked at first: a planetary alignment. On September 15th, as Earth was being battered by a storm of solar plasma, Mercury slipped behind the Sun, lining up in an exact position that some researchers argue could subtly alter the very balance of forces in our solar system. To the casual observer, it was nothing, just another day in the predictable ballet of planetary orbits. But to those who pay attention to the subtler rhythms of the cosmos, alignments are moments when the universe seems to hum at a different frequency, when gravitational, magnetic, and electrical forces can combine in ways we still don't fully understand. For some, this wasn't just coincidence. It was the missing link, the third piece of the puzzle connecting the sun above and the earth below. Mercury has always been a peculiar planet. The closest to the sun, it moves faster than any other, whipping around the star in just 88 days. Its orbit is tight, its magnetic field weak but still surprisingly complex, and its interactions with the solar wind are intense. When Mercury aligns with the Sun and Earth, even though its mass is small compared to giants like Jupiter or Saturn, it becomes part of an electrical and gravitational circuit that ties the solar system together. Some theorists argue that during these alignments, the solar wind is subtly redirected, magnetic fields become more entangled, and Earth caught in the middle feels the effects. To most scientists, these ideas remain speculative, fringe at best. But the timing in 2020, as the Sun erupted with a G3 storm, Mercury was in perfect alignment, hidden behind the blazing disk, as though adding its weight to the solar strike. 3 days later, Kamchatka's crust gave way in one of the most violent quakes in history. If the earthquake generator theory had already been unsettling, the alignment twist added another layer of mystery. For centuries, astrologers insisted that planetary alignments influenced events on Earth. Their claims were dismissed as superstition, mere patterns imposed by human imagination on the movements of the heavens. But modern science has quietly acknowledged that alignments do matter in some contexts. The pull of the moon and the sun together creates tides that rise and fall with clockwork precision. Jupiter's immense gravity tugs at the orbits of other planets, shaping the architecture of the solar system. Even small gravitational nudges, given enough time, can redirect asteroids or destabilize comets. So the question is not whether alignments have effects, but whether those effects can extend into realms we've been too cautious to explore. Could the delicate dance of planets, combined with solar storms, help set the stage for disasters here on Earth? Those who support this possibility often point to resonance, the phenomenon where even small forces can cause dramatic results if they arrive at the right frequency. A child on a swing doesn't need great strength to soar higher. They only need to push at the perfect moment, amplifying the motion with each cycle. In the same way, planetary alignments may act like subtle pushes in the solar system's resonance, amplifying the impact of solar storms on Earth's magnetic field. When Mercury slipped behind the Sun in September, its tiny gravitational tug may have been irrelevant by itself. But combined with the surge of solar plasma, the resonance may have shifted. Earth's magnetic field, already straining under the storm, could have been nudged just enough to cascade into instability. And if the magnetic field stirs, the crust may follow. Critics roll their eyes at such speculation, arguing that the distances and differences in scale make these effects negligible. Yet the universe is full of examples where small alignments produce outsized consequences. The tidal forces of Jupiter and Saturn keep their moons geologically active, heating their interiors and fueling volcanoes of ice and fire. Even Earth's moon, modest in size compared to the planet, drives ocean tides that shape coastlines, influence weather, and may even have played a role in the origin of life. If alignments can matter on those scales, why dismiss the possibility that similar effects might ripple through our world, especially when the evidence keeps stacking in suggestive patterns? The September alignment wasn't the only one raising eyebrows. Throughout 2025, multiple alignments have lined up with spikes in both solar activity and seismic unrest. In July, during the first Kamchatka quake, Venus and Mars formed a near line with Earth, a configuration some researchers believe may have enhanced geomagnetic fluctuations. Later in the year, as Atlas, the interstellar comet, drifted into view, Jupiter and Saturn entered positions that subtly altered the flow of solar wind. To skeptics, these are coincidences layered on coincidences. To believers, they are part of a pattern too consistent to ignore. It is as though the entire solar system is tuned to a rhythm, and when the instruments line up just right, the Earth is struck with the final note. There's something deeply unsettling about this idea, because it suggests that our planet's greatest disasters may not be entirely local. They may be written into the cosmic script, dictated not just by pressures building beneath the crust, but by alignments stretching millions of miles across the heavens. It means that earthquakes, volcanoes, even storms may carry echoes of planetary geometry, the silent music of celestial bodies influencing our fragile world. And while mainstream science may resist such claims, history has shown that the universe rarely respects the boundaries we try to impose on it. For those who lived through September's chaos, the alignment theory offered both terror and a strange sense of order. It suggested that the quake wasn't random, that it wasn't merely bad luck. It was part of a larger choreography, a dance of planets and stars that occasionally brings catastrophe down upon us. To the fearful, this was a nightmare because it meant disasters might be written in the sky long before we ever feel them. To the curious, it was fascinating, a glimpse into a hidden layer of reality where cosmic and terrestrial events are part of the same story. And to those who had long believed in the influence of alignments, It was vindication, the proof they had been waiting for, painted across the heavens and carved into the shaking ground. The planetary alignment twist adds a new dimension to the earthquake generator theory. It suggests that it's not just the Sun and Earth in this dialogue, but the entire solar system, planets, comets, alignments, and storms, all feeding into a network of forces that shapes our world in ways we don't yet understand. The September events were a reminder that we may be blind to the subtler threads connecting everything together, and as more alignments approach in the months ahead, the question grows heavier: will the next one bring another surge of chaos? Or will it pass quietly, leaving us to wonder what might have been? Perhaps one day, with better instruments and deeper knowledge, we'll be able to map these connections clearly, to see the full web of resonance and energy that ties the cosmos to our fragile planet. But until then, we are left with the eerie sense that alignments matter, that they are not just curiosities for astronomers, but forces that may decide the fate of millions. And in September of 2025, when Mercury hid behind the Sun and the Earth cracked open days later, the universe gave us one more reason to question coincidence, and to wonder whether the stars themselves are writing the story of our world. When the ground shatters in one corner of the world, the damage doesn't always stay there. Earthquakes are not just local events. They are global in their reach, sending seismic waves racing through the planet's body, rippling like a bell struck by an invisible hammer. The September quake in Kamchatka was so massive that seismometers on the other side of the world jumped in unison, recording the planet's deep vibrations. But hidden in this global resonance is an idea both fascinating and frightening: the possibility of antipodal echoes. In other words, when a catastrophic earthquake tears open one side of the planet, the energy may reflect, amplify, or even trigger instability directly opposite the rupture in the region known as its antipode. If true, it means that disasters can cast shadows across the globe, striking places that seem far removed yet are secretly tethered to the original quake. And when it comes to Kamchatka, its antipode lies near one of the most volatile zones on Earth, the Drake Passage, between South America and Antarctica. The concept of antipodal effects is not entirely new. Geophysicists have long known that seismic waves travel through Earth's layers in complex ways. Some bend around the core, some reflect back, some converge at points far from their source. On rare occasions, these waves can focus their energy on the exact opposite side of the planet, creating a kind of mirror strike. Evidence of this has appeared in historical records. After the colossal eruption of Krakatoa in 1883, reports of unusual seismic disturbances emerged near its antipode. Similar echoes have been suggested after other major quakes, though the evidence is often debated. Still, the idea lingers that Earth is more interconnected than we realize, and that no catastrophe exists in isolation. Energy does not vanish. It moves, it reflects, it seeks balance. And when Kamchatka cracked with an 8.8 quake, the world began to wonder where that energy might end up. The Drake Passage is not an innocent bystander in this story. It is one of the most seismically and geologically restless areas on the planet, a gateway between the Pacific and Atlantic where tectonic plates grind, oceans clash and storms rage with relentless force. The seafloor there is scarred by ridges and trenches, the scars of countless ruptures in Earth's history. To geologists, it is a place of constant tension, always near the breaking point. That makes it the perfect candidate for antipodal influence. If the seismic waves from Kamchatka did converge there, they would not find a stable bedrock, but a fragile, trembling landscape already primed to fail. The idea is chilling. One massive quake could beget another, its echo reverberating halfway across the world to awaken a second disaster. In the days following the September quake, instruments in South America did record unusual fluctuations. Nothing catastrophic, no great rupture tearing apart the land, but enough to raise eyebrows among those watching closely. Some speculated that these were the first signs of antipodal stress, a kind of distant aftershock that had yet to reveal its full force. Others dismissed it as background noise, the random chatter of Earth's restless crust. But the mere possibility was enough to fuel speculation. What if the real consequence of Kamchatka had yet to arrive? What if the quake was not just an isolated tragedy, but the opening act in a chain of global resonance, a drumbeat whose next strike would land far to the south? This theory taps into a deeper fear that disasters are not confined, that they spread like ripples across a pond. For centuries, people assumed earthquakes were purely local, but modern science has revealed that the Earth is an integrated system, its layers tied together by physics we are still deciphering. A quake in one region can influence activity thousands of miles away, either by relieving pressure in one spot or by increasing it in another. Sometimes these influences are subtle, unfolding over decades. Other times they are immediate, sparking quakes on the same day. The idea of antipodal triggering simply extends this logic to its extreme, suggesting that Earth's deepest vibrations can leap across the globe and find weak points on the opposite side. If that's true, then no place is safe, and every great rupture carries with it the risk of a hidden twin. The human imagination has always been drawn to symmetry, and the idea of antipodes plays into that instinct. The thought that Earth balances itself like a scale, releasing pressure in mirrored points, resonates with something intuitive, even poetic. But for those who live near the Drake Passage, there is nothing poetic about the possibility. Towns along the southern tip of South America already live under the constant threat of quakes and tsunamis. Scientists studying Antarctica worry that seismic activity in the Drake Passage could destabilize ice shelves, accelerating their collapse into the ocean. If Kamchatka's fury truly cast a shadow toward the south, the consequences could stretch far beyond immediate destruction, feeding into the slow, relentless march of climate change. In this sense, the antipodal threat is not just about another quake, it is about cascading crises, where one event triggers another, weaving a web of disasters that spans continents. Skeptics argue that antipodal theories rely too heavily on coincidence. Yes, quakes happen on opposite sides of the world, but with thousands occurring each year, some will inevitably line up by chance. And yes, the Drake Passage is active, but it is always active. To blame Kamchatka for its restlessness may be reaching too far. Yet the counter-argument is equally compelling. The largest quakes produce waves so powerful they cannot help but influence the entire planet. To deny that possibility is to ignore the physics of resonance. After all, Earth's free oscillations, its ringing after a great quake, can be measured for days, even weeks. If the planet is literally vibrating, how could that vibration not find sympathetic weaknesses, wherever they may be? The challenge lies not in proving the waves exist, but in proving they matter, and with every new megathrust quake, the evidence inches closer to that conclusion. What unsettles people most is the unpredictability. If antipodal echoes are real, they add yet another layer of uncertainty to disasters we already cannot predict. It means that a quake in Asia could foretell a quake in South America. It means that when the Earth roars in one hemisphere, the other must listen carefully for the aftershocks of fate. It suggests a planet more alive, more interconnected, and more precarious than we imagine. And in September of 2025, when Kamchatka broke open, many quietly wondered whether the Drake Passage was listening. Whenever something arrives in our skies that doesn't fit the rules, the human imagination leaps to the same haunting possibility. Maybe we are not alone. The appearance of Comet 3I Atlas, the third confirmed interstellar visitor to drift through our solar system, ignited that question like a spark on dry grass. For scientists, it was a triumph of observation, proof that our instruments are now sharp enough to spot wanderers born under alien suns. For the public, though, it was something more, a mystery cloaked in light, a cosmic stranger that seemed too strange, too timed, too extraordinary to be simply random. And as the details emerged, its coma stretching wider than the sun, its activity flaring far earlier than expected, its path cutting through the restless storms of solar cycle 25, whispers began to spread. What if this wasn't just a comet? What if its arrival was more deliberate, its timing more intentional? In short, what if we were looking at evidence of something artificial, a messenger or machine sent by minds we've never met? The scale of Atlas's coma was one of the first red flags. Half the size of the sun, shimmering with plasma as it interacted with the solar wind, it looked less like a comet and more like a controlled field. In theory, such a plasma envelope could serve as propulsion, harnessing the endless flow of particles streaming from the sun to steer across interstellar distances. Science fiction has long proposed plasma sails, or magnetic sails, as ways for advanced civilizations to travel without fuel, riding the currents of stars the way ancient sailors once rode the winds of Earth. And here in the middle of 2025, we had an object doing exactly that, or at least appearing to. Was it coincidence? Or was it a glimpse of the very technology we'd once only dreamed of, hidden in plain sight under the guise of a comet? Skeptics quickly stepped in, pointing out that comets are messy, chaotic things. They outgas unpredictably, They flare when exposed to sunlight, and their comas can expand in ways that seem extraordinary without requiring intelligence behind them. They argued that Atlas was unusual but not impossible within the framework of known physics. And perhaps they were right, but timing is everything, and the timing of Atlas's arrival was what unsettled so many. It came as the sun erupted into its stormiest cycle in decades. It came as Earth was shaken by twin quakes of historic magnitude. It came as geomagnetic storms painted auroras in skies unaccustomed to them. Against this backdrop, its presence felt scripted, like an actor stepping onto the stage at the exact moment of climax. If it was natural, it was nature at its most theatrical. If it was not, then the implications were staggering. For those willing to entertain the alien hypothesis, the possibilities sprawled in every direction. Was Atlas a probe, deliberately cloaked in comet-like material to disguise its true nature? Was it a derelict, a piece of ancient technology drifting without purpose, its original mission lost to time? Or was it something more active, a ship silently harvesting energy from the sun, or studying our world as it passed? Even the way its coma interacted with solar wind sparked speculation. Some amateur observers claimed to see fluctuations that looked patterned, as if controlled rather than random. Others suggested that its plasma field might be transmitting signals, hidden in frequencies we hadn't yet tuned. No evidence confirmed these ideas, but the mystery was enough to keep the conversation alive, whispered across forums, podcasts, and late-night discussions. What if it's not a comet at all? Of course, entertaining such thoughts invites ridicule. The scientific establishment thrives on caution, and rightly so. To leap too quickly into alien explanations risks discrediting the field. But caution can also blind us. For centuries, humanity has dismissed the extraordinary until forced to accept it. Once, the idea of stones falling from the sky was considered absurd, until meteorites were proven real. Once, the idea of other galaxies was laughable, until telescopes revealed a universe filled with them. The line between the impossible and the proven is thin, and Atlas stood squarely on it. Perhaps it was nothing more than a frozen relic, an interstellar snowball catching the sun's light in spectacular fashion. Or perhaps it was something else, something our instruments could not yet reveal, something that refused to fit into the neat categories we had built for comfort. What gave the alien question extra weight in 2025 was the feeling of convergence. Earthquakes, solar storms, planetary alignments, and now a cosmic visitor, all unfolding in quick succession. Each alone might be explained. Together they felt orchestrated, and when humans sense orchestration, they seek intent. Was Atlas a coincidence, or was it part of a larger pattern, a chain of events nudged into motion by forces beyond our comprehension? Some argued that if a civilization wanted to study Earth's seismic and electromagnetic systems, arriving during solar maximum made perfect sense. The planet would be most reactive, its systems most visible under stress. Others wondered if Atlas was a test, a probe gauging our response, watching how our scientists scrambled, how our people reacted to fear and wonder. The questions multiplied, and with them the unease. Even those who scoffed at alien theories could not deny the psychological power of Atlas's presence. Looking up at the night sky, knowing that a visitor from another star was there, glowing brighter than expected, carrying mysteries frozen billions of years ago, it stirred something primal, a reminder of how small we are, how vast the cosmos is, and how much we still do not know. For some, it was terrifying, the thought that alien technology might drift so close, silent and indifferent. For others, it was exhilarating, proof that the universe still held wonders capable of breaking through the noise of everyday life. Either way, Atlas had captured the imagination of the world, and imagination is often the first step toward discovery. The alien question may never be answered definitively. In time, Atlas will slip away, vanishing into the blackness, leaving behind only data and memories. We may never know if it was simply ice and dust, or something far stranger, but its presence has already changed the way we see ourselves. It has reminded us that we are not isolated, that the solar system is not a closed bubble, but a crossroad for travelers from the stars. And it has forced us to confront the possibility that one day one of those travelers may not just pass by, but arrive with purpose. Whether Atlas was natural or not, it has opened the door of imagination a little wider, and once opened, that door is hard to close. By the time September gave way to October, the world was holding its breath. The aftershocks of Kamchatka still rattled the earth, The auroras from geomagnetic storms still danced across unexpected skies, and Comet 3I Atlas continued to blaze with its outsized glow in the heavens. To many it felt like the planet had crossed a threshold into something unprecedented. As if the natural order of things had tilted off its axis, October carried with it an ominous sense of culmination, a feeling that the scattered threads of earthquakes, storms, and cosmic visitors were weaving together into a single, larger pattern, a nexus where every piece converged. No one could say exactly what was coming, but the tension was palpable, a global mood of unease, as if humanity collectively sensed that the story was far from over. The first days of the month did little to ease that anxiety. On October 2nd, solar monitors recorded a sudden surge in sunspot activity, the kind that hinted at stronger storms on the way. These dark patches, vast enough to swallow Earth whole, were windows into the sun's turbulent interior, where magnetic fields twisted and tangled before snapping free. To astronomers, they were expected during solar cycle 25's peak, but the sheer number and rapid growth of them suggested something unusual. Within days, a series of moderate geomagnetic storms swept across the planet, dazzling skies and disrupting communications yet again. For the average person, these were just more lights in the sky. But for those who had been connecting the dots since September, they felt like preludes, signals that the cosmos was not finished with us. Meanwhile, Atlas drew closer to its perihelion, its closest approach to the sun. As it did, its coma expanded even further, glowing with such intensity that some amateur astronomers compared it to a second sun when seen through sensitive instruments. Mainstream science insisted it was natural: solar heating, outgassing, plasma interactions, but the timing was impossible to ignore. Just as the sun grew restless, so did the visitor from beyond. The two seemed locked in a silent duet, each flaring brighter as the other stirred. For those drawn to speculation, the alignment of cometary activity and solar unrest seemed almost orchestrated, as though the arrival of Atlas had triggered the sun itself, or perhaps the other way around. On October 7th, the sense of convergence deepened with reports of unusual seismic activity in South America. In Chile and Argentina, tremors rippled through the Andes, not catastrophic but noticeable, enough to stir memories of the antipodal threat whispered about in the aftermath of the September quake. Scientists assured the public that the events were minor, unrelated to Kamchatka, but the timing, just weeks after the global shattering in the north, was too eerie for many to dismiss. It was as though Earth was playing a game of call and response, one hemisphere answering the other with its own low growl. For ordinary people, the thought was unnerving. For believers in the interconnectedness of all these events, it was confirmation that the nexus was real. By mid-October, the narrative reached a fever pitch. The sun erupted with its largest flare of the year, an X-class burst that hurled plasma into space at millions of miles per hour. Satellites scrambled to shield themselves, airlines re-rated polar flights, and power companies braced for potential surges. The flare missed a direct hit on Earth by days, but the near miss was enough to jolt the imagination. What if it had struck head-on? What if the next one did? With Atlas still in view and seismic tension still high, the world felt caught in a precarious balance. One push away from a chain reaction that no one could control. The sense of vulnerability was global, the headlines relentless, and the conversations at every level, from scientific circles to kitchen tables, turned to the same uneasy question: was something larger unfolding? It was around this time that whispers of prophecy began to resurface. From fringe forums to mainstream interviews, voices invoked Nostradamus, Mayan calendars, or modern psychics, who claimed to have foreseen a year of converging disasters. Normally dismissed as superstition, these claims now found fertile ground in a world already rattled. People wanted explanations, and if science could not provide them quickly enough, prophecy stepped in. October Nexus became a phrase used online, a shorthand for the idea that everything: quakes, storms, alignments, comets, was converging into a single moment of reckoning. The term spread like wildfire, carrying with it both dread and fascination, a symbol of humanity's need to impose meaning on chaos. The strangest part was that the phrase felt accurate. October seemed to hum with synchronicity. Each week brought another event that on its own might have been forgettable, but together formed a tapestry too intricate to ignore. On October 14th, auroras were recorded as far south as Italy and northern California, glowing green and purple in skies that rarely see them. On October 18th, volcanic activity spiked in Indonesia, with Mount Merapi releasing plumes of ash that blackened the sky. On October 22nd, Atlas reached its closest approach to the Sun, flaring with such intensity that its coma briefly became visible to the naked eye under dark skies. Each moment felt like a verse in a song, the melody building, the chorus approaching. And then came October 25th. That day, Earth was struck by a double storm, a geomagnetic surge from a coronal mass ejection, combined with the arrival of high-speed solar wind from another coronal hole. The storms tangled, amplifying each other, sending shockwaves through Earth's magnetic field. Satellites faltered, GPS signals wavered, and auroras blazed across half the globe. At the same time, a deep tremor shook the Pacific, not a surface quake, but a slow rolling convulsion of Earth's mantle, the kind scientists struggle to fully explain. The coincidence was too much. To many, it felt like the nexus had arrived, the moment when the threads finally wove together into one undeniable climax. Earth and Sun and comet, all resonating in unison, all reminding us how fragile our place in this universe truly is. The weeks that followed were marked by a kind of collective exhale. Nothing apocalyptic had struck, no extinction-level event, no global collapse. Life went on, albeit under skies that seemed angrier and ground that seemed less steady. But the memory of October lingered. People felt they had lived through a chapter in history, where the universe itself leaned close, whispering a warning. Scientists would later debate the coincidences, offering rational explanations for each event. They would insist that no hidden hand tied them together, and yet the narrative of October Nexus refused to fade. It became a cultural touchstone, a reminder of the fragility of order, the thin line between coincidence and pattern, and the possibility that the cosmos may hold connections we are still too small to see. Looking back, October 2025 stands as a month of convergence, when Earth seemed to hum with a different rhythm, when disaster and wonder intertwined, when the boundaries between science and mystery blurred into one. Whether it was mere coincidence or something greater, the world had felt the weight of it, and that feeling could not be undone. October Nexus was not just a phrase, it was an experience, one that reminded us that our planet is not an island, but a node in a vast, living web of forces that stretch across the stars. While the world was captivated by the dramatic scenes of auroras, earthquakes, and a glowing interstellar visitor, something quieter was happening in the background, so subtle that most people never noticed it at all. These were not the booming roars of seismic ruptures or the dazzling storms in the sky, but faint, almost imperceptible disturbances that hinted at forces moving beneath the surface of ordinary life. Scientists call them anomalies, strange hums in Earth's magnetic field, unexplained fluctuations in radio signals, mysterious low-frequency vibrations that seem to come from nowhere and everywhere at once. To the untrained ear, they were silent. To the instruments that tracked them, they were whispers of something deeper, signals that spoke of a planet responding to pressures we cannot yet see. And in October 2025, those whispers grew louder, as though the Earth itself was trying to speak. One of the most intriguing of these anomalies was the reappearance of the Earth hum, a faint vibration first documented decades ago. Unlike earthquakes, which release sudden bursts of energy, the Earth hum is a continuous, low-frequency oscillation that can only be detected with the most sensitive instruments. For years, scientists debated its cause. Some thought it came from waves crashing on continental shelves, others from atmospheric turbulence, and still others from deep processes in the mantle itself. But during the weeks following the Kamchatka quake and the October solar storms, the hum shifted. Its frequency changed subtly, its rhythm altered, as if the planet had adopted a new heartbeat. Researchers at monitoring stations in Japan, France, and South Africa all reported anomalies, their data showing a pattern that defied conventional explanation. It was as though the entire Earth had been tuned to a new note, humming in resonance with the cosmos. At the same time, strange disruptions began appearing in radio communications. Amateur operators, who often notice anomalies before professionals, reported bands of static that appeared and vanished with no connection to solar flares or atmospheric interference. These signals pulsed irregularly, almost patterned as though carrying information. Some dismissed them as artifacts of equipment malfunction, but others grew convinced that they were real, that the planet was broadcasting something beyond our comprehension. A few conspiracy-minded corners of the internet immediately tied these signals to Comet Atlas, suggesting that the interstellar visitor was not just a comet, but a transmitter, using Earth's magnetic field as a medium. Scientists scoffed, but even the most cautious admitted that the anomalies were unusual, arriving at times that coincided suspiciously with solar activity and seismic events. Perhaps the most unnerving of all were the reports of skyquakes, loud booms heard in various parts of the world, with no visible cause. From rural villages in Argentina to coastal towns in the United States, people described hearing explosive sounds, sometimes accompanied by rattling windows or brief flashes of light. Military officials insisted these were sonic booms from aircraft or small meteor entries, but the explanations often failed to align with the timing or location. In several cases, seismometers recorded faint spikes at the same moment the booms were heard, suggesting a coupling between the ground and the air, a burst of energy too localized to be explained by global quakes, yet too widespread to be mere coincidence. To those paying attention, the booms were not random. They were part of the silent signals, evidence that something was moving beneath the veil of normal perception. What made these anomalies even more chilling was their synchronicity. The hums, the static bursts, the skyquakes, all seemed to cluster around key events: the solar storms, the flaring of Atlas, the tremors in South America. It was as though each visible disaster had an invisible echo, a shadow written not in fire or stone, but in frequencies and vibrations. Scientists struggled to make sense of it, rushing to gather data before the anomalies faded. But for many outside the scientific world, the impression was clear. The Earth was communicating, whether with itself, with the cosmos, or with something we could not yet name. It seemed to be sending signals, messages too complex for us to decode, but too consistent to ignore. This was not the first time humanity had encountered such mysteries. In the late 20th century, researchers discovered whistlers, eerie descending tones in radio frequencies caused by lightning discharges traveling along magnetic field lines. In the early 21st, they detected spherics and chorus waves, strange chirping sounds produced by interactions between plasma and the magnetosphere. Each time, the discoveries revealed hidden layers of Earth's dialogue with space. But the anomalies of 2025 felt different. They were not just atmospheric curiosities, but global, synchronized, tied to seismic and cosmic upheaval. They felt intentional, even if no intention existed, and that sense of design, of structure within the chaos, is what kept people awake at night. To the ordinary observer, the silence was deceptive. Life went on. Planes flew, phones buzzed, cities pulsed with electricity. But beneath it all, the silent signals persisted, unnoticed by most, yet shaping the thoughts of those who knew they were there. For believers in the alien hypothesis, the signals were confirmation. Atlas was speaking, and Earth was responding, the two locked in a dialogue beyond human understanding. For spiritualists, the hums and booms were omens, proof that the planet was alive, crying out under the weight of cosmic forces. For scientists, they were puzzles, frustrating and exhilarating, data points that hinted at breakthroughs just out of reach. Each interpretation carried its own weight, but all agreed on one thing: silence was not silence anymore. It was filled with meaning. By late October, the anomalies had spread into mainstream discussion. News outlets reported on the hum, framing it as a curious side story to the month's larger disasters. Podcasts dissected the static bursts, weaving them into theories about planetary alignments and interstellar visitors. Social media filled with recordings of skyquakes, grainy audio that sounded like distant thunder but carried an uncanny edge. The narrative of October Nexus gained another layer. Not only were quakes, storms, and comets converging, but the Earth itself seemed to be whispering about it. The silent signals became part of the mythos, amplifying the sense that humanity was living through a chapter of history where the unseen was as important as the seen. In quieter moments, when the auroras faded and the tremors paused, some found the signals strangely comforting. If Earth was humming, it meant the planet was alive, dynamic, part of a cosmic orchestra that stretched from the core to the stars. The thought that we were participants in that symphony, even unknowingly, gave people a sense of connection. But for others, the hum was terrifying. If the planet was sending signals, it could mean distress, a prelude to something worse. The silence was no longer empty, it was a warning, and when you don't know how to read a warning, fear is the only natural response. The silent signals of 2025 may never be fully explained. Perhaps they were natural, the byproducts of a stressed planet, resonating under cosmic pressure. Perhaps they were coincidences, patterns imposed by human imagination on random noise, or perhaps they were something more, glimpses of a deeper order we are not yet capable of seeing. What matters most is how they felt, how they turned silence into mystery, how they made people listen to the spaces between disasters as much as the disasters themselves. They reminded us that not all messages arrive in fire and thunder. Some arrive quietly, in hums and whispers, waiting for us to pay attention. And in that silence, Earth may be telling us more than we are ready to hear. As the dust of 2025 begins to settle, the world is left with more questions than answers. Earthquakes, auroras, solar storms, planetary alignments, an interstellar visitor, and a chorus of strange signals all collided within months, forcing humanity to reconsider its place in the cosmic order. Each event on its own might be explained: tectonic strain releasing after centuries, sunspots erupting during a predictable solar cycle, a comet passing by on a chance trajectory. But together, their convergence painted a picture too intricate to dismiss as coincidence. It felt as though the planet and the cosmos had been playing in sync, each movement reflected in another, weaving a narrative that unfolded across both sky and soil. And whether we choose to interpret it through science, speculation, or symbolism, one truth remains: the world is far less stable and far less separate from the universe than we often allow ourselves to believe. What makes this realization so haunting is the reminder of how fragile our sense of control really is. We build cities on fault lines, string satellites across the sky, and draw invisible borders on maps, pretending that these constructs can hold against forces millions of times greater than ourselves. Yet in a single quake, a single solar storm, a single unexpected visitor from beyond, those illusions unravel. The events of this year showed us that the Earth is not an island, but a participant in a system of unimaginable scale. Our planet hums, quakes, and glows not in isolation, but in response to energies flowing from the sun, the stars, and perhaps even the deep unknown. The boundaries we draw between geology and astronomy, between local and cosmic, are human conveniences, not cosmic truth. And yet, there is something deeply human about the way we search for meaning in this chaos. Some turn to science, tracing the delicate threads of electromagnetic currents, seismic pressure, and solar plasma. Others turn to speculation, imagining alien technologies cloaked as comets, or planetary alignments shaping our fates. Still others turn inward, sensing in these events not random chance but messages, omens, warnings that speak to us in the language of storms and quakes. Perhaps the truth is not one or the other, but all of them at once. Perhaps science, myth, and mystery are just different ways of trying to touch the same vast reality, each one offering fragments of a truth too large to grasp in full. The conclusion, then, is not an ending, but an opening. The earthquakes may subside, the comet may vanish into the dark, the auroras may fade, but the memory of it leaves us with the sense that the world is alive in ways we have barely begun to understand, that the silence between disasters is filled with signals we are only starting to hear. It leaves us with the awareness that we are small, fragile, and vulnerable, but also that we are witnesses to something extraordinary. A planet that is not just a rock spinning in space, but a living node in a cosmic web, forever influenced. And if that realization feels unsettling, perhaps it should, because the universe has never promised us safety, only wonder. And as long as we keep watching, listening, and asking, we will remain part of the story, no matter how terrifying or beautiful it becomes.